In this problem, we're asked to find all the key features of a rational expression right here. And you'll see I've already written one of these steps, which is I factored it before the video started, because honestly, this video is getting a bit long anyway. Now, if you don't know how to come up with this factored form, we've been over this many times. It has to do with the big X and what you do when the numbers at the front are not equal to 1. Okay, so you can go back and look at any of the old videos for factoring, and those will work just fine for you. The trick to this one is realizing that this thing up top here is not really a cubic polynomial. It has a GCF of X, and that makes the factoring much easier. Okay, so with that being said, let's move on to the x-intercepts, y-intercepts, and all the rest. Now, what are x-intercepts? Those are factors on the top which are not on the bottom. So I have one of those right here, 4x plus 5. So the x-intercept is at negative 5 over 4, comma 0. And where did that come from? Well, we solved it. 4x plus 5 equals 0. So that's 4x equals negative 5, x equals negative 5 over 4. Great. Y-intercepts. For y-intercepts, these things are very nice. What you do is you set all the x's equal to 0, right? So for y-intercepts, I'm going to say x equals 0. Now, what happens when x equals 0? 0, 0, 0, 0, 0, right? Almost everything cancels out. All we get in the end is 0 over 15, which is 0. So x equals 0, y equals 0. And this points out something that I forgot. Great. See those x-intercepts? I missed a factor. Find another factor of x that's not on the bottom, but it is on the top, right? It's just so simple. It's sitting there in plain sight, that x, which is, you should read that as x minus 0, which solves to 0, 0. Okay, so we have another factor of 0, comma 0 right here. And the way you write two x-intercepts is you just put a comma between those parentheses. Okay, just like I've written here. All right, so that's x-intercepts and y-intercepts. Let's move on to, I don't know what's next. Oh, we got a hole in the function. Okay. So I'll use orange for this one. And I see a factor which is on both the top and the bottom right here, x minus 5. So that tells me the x location of the hole, which is 5. The y location is going to take a little bit more work. What you have to do is evaluate the function in its simplified form, right? And when I say simplified form, I mean you're going to remove the discontinuity. That's why holes are called removable discontinuities, because you can cross that out. You're going to evaluate the function at x equals 5. Okay, so that's 5 times 4 times 5 plus 5 over 2 times 5 minus 3. And I'm going to save us a little bit of time and just skip to the answer here. If you go through your calculator and figure this out, or just do it by hand, it's going to be equal to 125 over 7. Okay, so the way you would write that is, well, the x location is 5, and the y location was 125 over 7. Now, maybe the problem that you're doing is different than mine, and you didn't have a hole, like a common set of factors from the top and the bottom. It would be a D and E, okay? And then maybe you'd have another x-intercept that I did not have. But the process that you're following is the same for all of these. So let's move on to vertical asymptotes. These are factors which are on the bottom but not on the top. So I see one right here, 2x minus 3. So that, if you solve it, 2x minus 3 equals 0. That means 2x equals 3. That means x equals 3 halves. Okay, so right here, that's x equals 3 halves. Okay, so that one's done. And the horizontal asymptote. Well, think about what it takes to have a horizontal asymptote. You need a function that is equal weight or bottom heavy. And this right here is top heavy. This is a top heavy rational. And top heavy means oblique asymptotes. So the horizontal asymptote is a big D and E. That one's nice and quick. But the oblique asymptote is not quite so quick. Now what I'm going to do here, I want to grab this whole factored equation that we went to so much work before the video to find using the big X method. I'm going to bring that down here. And we're going to work on this for a little bit to find that oblique asymptote. Let me just clear some of this stuff out of the way. Okay. Now, when you're trying to find the oblique asymptote, what you do is you remove the whole first. We have to do synthetic division here. And the more factors in the denominator, the more times I have to do synthetic division. Okay, if you have 2 factors, fine, you have to go through synthetic division twice, and we've done that before. But in this case, I really only have 1 need for synthetic division. Okay, so I'm going to go ahead and I'll work this through. This is, remember, this is 4x squared plus 5x over 2x minus 3. So in the synthetic division, that's going to be 3 halves to the left. My coefficients are 4, 5, and 0. Okay, so bring that down. This becomes pretty quick. I get 4x plus 11. Now we're not done yet, because we have this factor of 2 right here. And that factor of 2 has to be remembered as a division. Okay, synthetic division is just a hack. So when you try to find the oblique asymptote, you have to remember, if there's a number in front of that denominator as a leading coefficient, you have to divide by that at the end. This becomes y equals 2x plus 11 over 2. That is our answer to the oblique asymptote. Okay? Now, you can quit if you're done with this, but I just want to go over how you would handle 2 factors right there. I want to do this again, but with 2 factors, just in case you missed that from one of the earlier videos. So what I would do is I would take my fully factored form, my unfactored form, which is this guy. Okay, 4, negative 15, negative 25. Let's take those coefficients. 4, negative 15, negative 25, and 0. Those are our initial coefficients from the unfactored form. And I'm going to start working through, let's start with the negative 5 first. And I'm going to color code this so we can kind of tell what's going on here. Negative 5 is up front. 4, 25, 25, 0. Now, we do a second round of synthetic division on the second factor, okay? And this would be that 3 halves. I'm not going to go through this part because we just did that. See? That's this thing right here. Right there. That's exactly the same thing. The only step I skipped was that removable discontinuity. And if you don't have a removable discontinuity, you won't skip that step.